This video covers the elbow model portion of your Chapter 9 lab. So here is the elbow model. It's a plastic arm and the elbow can bend. And to start off, to just kind of get some orientation, we label the parts of it. So you have up here the humerus. Remember, that's the one bone in the upper arm. Then down here, we have the radius and ulna. Those are the two bones of the forearm. Now, one of the things that can be confusing to figure out at first is which way does it bend? So does it bend this way or does it bend this way? Well, you look at the olecranon to figure that out. Remember, you have a funny bone, like if you look at your elbow, you have that point there, that funny bone that feels weird when you hit it. That's your olecranon. And that goes on the bottom when your elbow bends. So we know that this is the correct direction it bends because that puts that olecranon on the bottom. So this would be the opposite. This would be like bending your elbow backwards. You can't do that. So here is this elbow model when the arm is extended, and then when you flex, it flexes this way. And remember, when your arm is flexed, the radius is on top by your thumb, and the ulna is underneath. So that's how you can think if you're giving a thumbs up, the ulna is underneath. Okay, then the next few questions you're going to use your notes and your book to answer. So we will go ahead to number 12 here. Use a rubber band to represent the biceps brachii. Have the biceps contract. What happens? What is the name of this movement? So I have a couple of rubber bands here. The biceps is in the front. It's the anterior. And the biceps connects to the radius. So we have the biceps up here. We're going to connect it down here on the radius side. And when we do, it bends your elbow, which is flexion. Okay, now we're going to go to number 13. Now use a rubber band to represent the triceps brachii on the model. Have the triceps contract. What happens? What is the name of this movement? So remember, the triceps is on the posterior side. So back here is the triceps. And it connects to the olecranon, which is part of your ulna. So we connect that, and the elbow straightens out, which is extension. Okay, the next few you're going to get by looking in your book. Carefully look in your book, look at the pictures. Then we come down here to the 3 different pegs. So on the radius, it gives you 3 different options of where you can attach the biceps. So we're going to experiment with those 3 pegs. So we're going to go ahead, we're going to take the triceps off because we're just going to experiment with the biceps. So here we have the biceps connected to that first peg, which is peg B. So it goes B, then C in the middle, then D at the end. We can just call it the closest to the elbow, or the more proximal one. And we want to look at strength and range of motion. So if I pull the arm down, and you just kind of look at how forceful it comes back up. And if I put my hand here, so that you can kind of see how hard it hits my hand. Okay, so there's an idea of the strength. It's kind of weak. If we look at range of motion, can we straighten this all the way out? Now remember, your muscles, we don't want to bend them backwards like that, right? So we're going to see how far we can straighten this out. And that's your range of motion. And with it attached at the closest, the most proximal peg, you can get full extension. Now let's go ahead to the further peg. Okay, so let's see how forcefully it flexes. Wow, that's a lot stronger. We'll do that again. Like you can even hear that, it slaps back up. So you have a lot more strength. The further a muscle attaches out from the joint, the more distal from the joint your attachment, the more strength you get. But let's look at range of motion. If we try to straighten this out, about here is all the further we can get. If we keep going, we're going to bend that muscle backwards and we can't do it. So we can't get the full extension. We can only get just a little past 90 degrees when we're here. So if you have a muscle attached distal from the joint, it's stronger, but you can't get full extension. You lose range of motion. If you have a muscle attached proximal to a joint, it's weaker. See, it doesn't slap back hard. It doesn't make that noise. You don't have as much strength, but you do have a much greater range of motion. We can get full extension there. So now think about which one is your arm. Can you fully extend your arm? So use that to help you figure out the last couple of questions here.